Bubbly, bubbly. Bubbly, bubbly. Set it!
Geometric sequence is a sequence in which each term after the first term A is obtained by multiplying the previous term by a constant r, called the common ratio. It is obvious that A is not equal to 0 and r is not equal to 0 or 1.
So let's try.
Compute for the first 5 terms of the sequence 3, 6, 12, and 24. First step, you should write the equation first, which is a sub n equals a sub 1 times r raised to n minus 1. Third step, then you have to look for your ratio. In order to find your ratio, you simply divide your second term with your first term. Then the answer will be your ratio, which is 2. Fourth step, now look for the n. Your n is the number of terms you are looking for, which is 5. Fifth step, since your n is 5, you have to subtract 1 to it. It will now be a sub 5 equals 3 times 2 raised to 4. Then multiply 2 raised to the 4th power, and the answer will be 16. Sixth step, since your a sub 1 is 3 and your ratio is now 16, you multiply both of them. Seventh step, we are almost done. Since the answer you got by multiplying your a sub 1 to your ratio is 48, then you are now done. You just have to complete the answer by writing a sub 5 equals 48.
Let's try another.
Solve for the 10th term of the sequence 4, 12, 36, 108, and 320. First step, you should write the equation first, which is a sub n equals a sub 1 times r raised to n minus 1. Second step, you have to look for your a sub 1. A sub 1 is your first term, which is 4. Third step, then you have to look for your ratio. In order to find your ratio, you simply divide the second term with your first term. Then the answer is your ratio, which is 3. Fourth step, now you have to look for the n. Your n is the number of terms you are looking for, which is 10. Fifth step, since your n is 10, you have to subtract 1 to it. Your equation will now be a sub 10 equals 4 times 3 raised to 9. Then, you multiply 3 raised to the 9 power, and the answer will be 19,683. Sixth step, since your a sub 1 is 4 and your ratio is now 19,683, you multiply both of them. Since the answer you got by multiplying your a sub 1 to your ratio is 78,732, then you are now done.
Now, let's try this word problem.
A swing set swings 20% shorter than its previous swing. If the first swing is 50 centimeter long, how long will be its fourth swing? First step, you change your percent to its decimal form by moving the decimal point 2 places to the left. So, 20% will turn into 0.20. Second step, to solve for r is 1 minus the decimal point of the percent. The minus sign varies because it depends if your situation is increasing or decreasing. Since our problem shows a decreasing action, we will use subtraction. So, 1 minus 0.20 and the answer will be 0.8. Therefore, 0.8 is now your r. Third step, you can now use your geometric sequence, which is a sub n equals a sub 1 times r raised to n minus 1. Your a sub n will be a sub 4, since you're looking for the fourth swing. Your a sub 1 will be 50 because it is your first term. Substitute your r to the equation, which is 0.8. Lastly, your n will be 4. Fourth step, Start with r and its exponent, so 4 minus 1 is 3. You raise 0.8 by 3 and the answer is 0.512. Now your equation will be a sub 4 equals 50 times 0.512. Fifth step. Multiply 50 by 0.512 and that will be your final answer. 50 multiplied by 0.512 will be 25.6. Your final answer is 25.6, which is the fourth swing.
And that is all. To easily remember the formula, remember this.
Electric sequence go! Ace of n equals to ace of 1 multiplied by r raised to n minus 1.